Chapter name is Physical World. It is the first lecture of this physics subject. Yeah, your head is right. This is the first lecture, and this is the first chapter of the physics subject. And name of this is in front of you. Is that physical world? Let's start. Are you serious? Are you ready? I am ready. I am also serious. I want to start. So let's start with this. Our learning objectives are scientific method. Then what is the physics? What is the meaning of a physics subject that we selected? Then impact and uses of physics, a scope of physics, fundamental forces, unification of forces. You will understand importance of physics. You will see impact of physics. When we will use physics, then what will be impact and how to use, why to use, when to use, what to use in physics. So something we will be using, then we will get impact, something we will get. And what is the scope? Is there a scope of physics in real life? Fundamental forces will be covered. Let's see. We are starting with a question. Question is that what is a science? It's not what is a physics. It's what is a science. Now we can see there is a figure. In figure, what are you realizing? Here you are realizing a sky. Okay. Then this lightning, thunder, then this planet, all these planets, then this earth, then this ocean, birds, a sky, then so whatever we saw right now, whatever we saw pictures, all we discussed, we express all this nature. Whatever right now we saw pictures, all these are nature. From a sky to the land, from universe to the ant, all these are nature. Whatever happens by nature, we study this, and this is what is physics. We see that yes, something is in rest. What is the reason behind this? How is it able to be in rest? In your mind would be coming a lot of question when you will be taking lectures of physics then. And answer of all this you will get from this lecture. So science is a systematic attempt to understand natural phenomena. Yeah, natural phenomena, which means there are a lot of there are happening a lot of things which are depend on nature, and we study nature of this real nature. To understand natural phenomena in as much detail and depth as possible, we study this natural phenomena, and we can study this natural phenomena as much as it can be possible, and we go in depth. Knowledge gained to predict, modify and control phenomena. We can modify, we can control phenomena, and in this we will be gaining knowledge. Science is exploring, experimenting, and predicting from what we see around us. Yes, science tells you that explore, you experiment, you do experiment, and then whatever you think, if it is possible to bring your thoughts into real life, then take action. Science is saying to you. Don't just think. After thinking, try to take action so that your thoughts can be brought in a real life. Okay? And here, first you will think, then after thinking, you will get idea, then you will take action. And here, if you don't get success in one time, then it doesn't mean that you will stop. No, no. You can more experiment so that you can have experience. Okay. Remember, if you explore anything, then you go in depth. You think, yeah, this is wrong, this is right. Why should you select this? Why should you not select this? You obtain a lot of things. You observe a lot of things while exploring anything. Exploring is not useless, rather, it is a useful in any field. If you are a student and you are exploring website, then you will see, yeah, this is how website works. By this website can be gain this type of knowledge. A lot of things you will be getting, yeah, through exploring and through experimenting. You see that your whatever you think and then you take action, you are going to create that you want, think that you want. Predicting, which means future, whatever you are thinking that it should be made, so it is a predicting. Okay. Now next, systematic observation, controlled experiments, qualitative and quantitative reasoning, mathematically modeling, prediction and verification of classification of theories. All these are what we observe to science. We observe natural phenomena. We can control nature, quality and quantitative reasoning, mathematical modeling. We see that there is a connection of a mathematics with physics. We can see, and most of you would be knowing that yes, without mathematics, physics is incomplete. Yes, physics is incomplete without mathematics. Both are sibling. Okay. Now, unification. Unification. What is unification? Unification explains diverse physical phenomena. It explains diverse physical phenomena in terms of a few concepts and laws. There are some phenomena which can be seen physically. They are physical phenomena. For example, ocean, water. Uh, Air is not physical. Okay, air is not physical. We cannot see directly. So, land is a physical phenomena. See the physical world as a manifestation of some universal laws. Example, law of gravitation given by Newton. Yeah, we know that it is given by Newton. So law of gravitation is what it can be observed, and you know that this is not a physical phenomenon. It is a phenomenon, but this is not physical phenomenon. We cannot say directly it. Okay. The next, basics, basic laws of electromagnetism. Basic laws of electromagnetism. Maxwell's equation govern all electric and magnetic phenomena. Basic laws of electromagnetism. electromagnetism, which means Maxwell equations, basic law of electromagnetism. Unification. Here, this figure is telling you about Newton, about gravitational force, and you are familiar with this. A apple falls down, falls down on the head of Newton, sir, and then he start he starts thinking why did it fall. Then he did a lot of experiment. During experiment, he realized a lot of things. Then something he wrote for us that we are going to understand. With proof, he wrote. Behind this figure, we have a Earth, which is rotating at a fixed point. What is the reason behind this falling apple? We know that this is a gravitation. What is the reason behind this rotating Earth? There would be reason. Why does it not fall down? Why? You would say gravitation. And this is what we observe. This is what we study in physics. Now here, there are some planets which are moving around the sun. They are able to move circularly because of centripetal force. Yeah, this is a concept that is taught in separate lecture, in lecture of gravitation. Right now, you have to understand that yes, they are able to make a circular path because of a centripetal force. And behind this happening, all this phenomena, reason is that gravitation. Now satellite is in a space. It is in orbit. Why? Because the reason is that gravitation. Fundamental concepts of physics. Fundamental concepts of physics. What is happening over here? Here you will see we will see it later. We know this website. Don't worry. Here reduction test to drive the properties of a big complex system interaction of its constituents simpler parts. For instance, temperature, pressure, elasticity. All these are studied in physics, and these are fundamental concepts of physics. What is the temperature? What is the pressure? Elasticity? You will have to understand it. Then ahead of it, you will be able to understand all the advanced topics of physics. But these are fundamental concepts. So to drive the properties of a big complex system and interaction of its considers simple parts, we will have to understand these fundamental concepts of physics. Gravitational force. This is just a type of a force. This is just a type of force, which is a gravitational force. And it can be also called as a downward force, because something is upward, then after releasing that object, then that object will come downward. So this downward force is just a gravitational force, and gravitational force is defined as a lot of things attract to each other, and this attraction force is just a gravitational force. This attraction force is called gravitational force. And remember, only two or more objects will attract, not will repel. Only will attract. It is also said that yes, gravitational force is a weakest force. Yeah, we saw in the chapter of gravitational force. We saw that this is a very weakest force. Even right now, in front of me, there are some objects, and these objects are attracted to each other, but with a some very less force. With a very less force. In this case, height will matter. In this case, mass of the object will matter. In this case, distance between two masses of objects will matter. We have studied this as a chapter. Now next, here, this is about this gravitational force. What is it talking about? This is telling you that you have two objects. This is m1. This is the mass of this object, and this is mass of this object. We know that mass of this object is more, and mass of this object is less. And this is attracting with this much force. This is attracting this object with this much force, and this is attracting this object with this much force. Both attract with equally force. If this is applying how much force? That's just a 16. So this will be also applying 16. Here we can see just opposite. And here from the center of the first object, we measure it distance from this center of the first object until the center of the second object, and this complete will be distance, and it will be represented as r. This f1 is for this f2 is for this, f is a force, m is a mass, okay, j is a gravitational. This formula is used to calculate a gravitational force, and here with the help of this formula we are able to find that with how much force they are attracting to each other, with how much force. So with the help of this formula we are able to calculate. Now attractive in nature, yeah, we know that this is attraction. Universal force, it is also known as universal force. Weak force, yes, we know this is a weak force. Weak force governs the motion of earth, planets and gravity. Next, electromagnetic force, this is also a force, and here it behaves like a magnet, but yes, it will behave like a magnet. If charges, here, hold on, electromagnetic force, I think so. If you talk about charges, electric charges, then what happens? If electrons are same, okay, this is side and this side, both are electrons, then in that case both will repel to each other. But in this we have, in the other case we have in this hand what, a proton, okay, proton, and in this hand we have neutron. In that case this neutron, both will attract to each other, okay, both will attract. So I can say this proton will attract this electron. Here our focus is on sign of this both atoms. So here this is a minus and this proton is considered as a plus. So if both signs are different, then they will attract to each other. If both sign of both are same, then in that case both will repel to each other. This happens with the charges. Here, what is happening over here? You can see. Yeah. it is a talking about is electric charges. Here you can see both are protons, both are protons. So in that case, what will happen? Both are repelling to each other. If both sides, if you have one this side a proton and this side an electron, then in that case both will attract to each other. Both will attract to each other. But both are electron, then both will repel to each other. This is known as electromagnetic force, and it is behaving like a magnet. Magnet does same, attractive and repulsion. Yeah, act on a pair of yeah, a strong force. Yeah, it is a strong force. We know this is very strong force. Next, electric and magnet. A strong nuclear force. It is also force, but a strong nuclear force. I hope I am not familiar with this, but let's see. Strong force. We are talking about strong force, electromagnetic force. Yeah, this is about electromagnetic force. Here, what is happening? This is what this is considered as. This is known as nuclei. Nuclei, and this red is known as what? Proton. Here you can see. What is happening? What is happening over here? This is telling you that it is going like that. In that case, what is happening? They are making a strong force. They are making a strong force. Same here you can see. Bands of protons and neutrons. Bands, protons and neutrons. I think so. These are neutrons and these are protons. Red colors are protons. Without red colors are neutrons. Attractive in nature. Okay. 100 times stronger than electromagnetic force. Yeah. This is a nuclear force and this is an electromagnetic force. It is 100 times stronger than electromagnetic force. Here you can see how are they making strong themselves. We will bring this topic as a chapter in separate chapter. Charge independent. They are not dependent on other. They are independent. Range is very small. This much. This much small. We will see it later. Weak nuclear force. Seen in nuclear processes such as B, like stronger than gravitational force but weaker than strong nuclear force. Charge independent, range is very small, this much. Okay. Here try to understand. This strong force bends the nuclei. Strong force. These are protons and these are neutrons. Electromagnetic force bends atom, and here weak force in a radioactive decay. Gravitational force bends the solar system. Solar system. Branch in physics, optics. This is branch. Behavior of light. In optics we will see behavior of light. In electromagnetism we will see electricity, then magnetism and AM waves, then a nuclear structure of the nucleus, energy associated with the nuclear charges, then we have a branch in physics, which is atomic structure of the atom, energy associated with atomic changes, then vibration and waves, which is what sound, periodic motion, then mechanics, motion and its cause, then we have last which is thermodynamics, heat and temperature. Till 10th we have seen what light, basics of light, then basic of electricity, this one 2, then this vibration and waves 3, then motion and 4, uh, human eye, magnetic effect. I think magnetic effect will come in this. So 1 2 3, so all chapters of the physics of 10th class are important, are necessary to understand, because they are coming in this standard, that's why. Next we have use and impact of physics. We can see uses and impact of physics in this laptop. These were made by using physics concept, and today we can see impact of this computer, this refrigerator. In this you can see something are working which are possible because of physics. In this you will see something will be moving because of motion. And this electricity is provided. Here this light is coming, optics. And this is something, a small thing will be working in a motion. Apart from this, there are more uses of physics in this. Here satellite, it is moving, and this is concept of motion of a physics. And there is a force which is nothing but gravitational force, and it is a concept of physics that is being used over here. This is a nuclear, it is very dangerous, and we have a separate lecture of a nuclear, don't worry. Atomic, atoms, all this will be discussed in a separate lecture. Question to think and discuss. Through India now has a large base in science and technology, which is a fast expanding. It is still a long way from realizing its potential of becoming a world leader in science. Name some important factors which in your view have hindered that advancement of science in India. Okay. Now, physicists has ever seen an electron, yet all physicists believe in the existence of electrons. An intelligent but superstitious man advances this analogy to argue that ghosts exist. This is for you, and this is question. We know that India is becoming a science factor. Uh, there are a lot of people who are in India country. They are exploring science. They are exploring science. A lot of people from India are doing better in the field of science. This first question is the same in the upcoming future. The role of India in science will be larger. Our India will become a well science structure, part of the, not part but leader of the world as a science. That's all about this. In this was the first lecture about physical world. Now let's take next chapter, next lecture. Next is units and measurements. Units and measurement. Hold on. It's a second lecture. Now we have started. Name of this lecture is units and measurement. There are a lot of units of a quantity and there are a lot of measures. We will study about the quantity. What is a quantity? What is a scalar? What is a vector? There are a lot of quantities and units of there we will be discussing. So these are our learning objective in this, and here you can see physical quantities and units, measurements, errors in measurements, significant figures, dimension analysis and its application. All these are going to be our learning objective for this lecture. We will start with physical quantities and units, then we will end with dimension analysis and its application. Let's see. So we have started physical quantities and units. In this topic we have this much learning objective. First, introduction of a physical quantity, then units, then system of units. Let's begin. Here physical quantity is what? There are some quantity which can be measured, physically and unphysically. Here can be measured. Okay. If you are able to measure anything, then that thing will be physical quantity, and that physical quantity will be studied as a physics subject. So here is a mass a physical quantity? Answer would be yes. I think it should be yes. Yes, mass is a physical quantity. We can measure mass by balance and weighing machines. Yeah. But what if I say that is heat a physical quantity? So answer would be no. We cannot measure a heat. Heat, not heat. Enemy, good. All these are not physical quantity. These are quantity, but not physical quantity. Physical which means? Okay, we will expand it later. Yeah, mass can be measured. Next, yeah, here. It is a machine that is used to weight something. Now next, is favor a physical quantity? Yes, answer is yes, because it measures something. It measures a temperature, yeah. It measures the temperature of a body, of a living thing. No, is favor. This is not a device. Okay, favor. No, answer wouldn't, because it is a disease. We use a device to measure fever. Now doctor did not measure fever, he measures the temperature. Yeah, temperature is a physical quantity which is measured by the thermometer. Yeah, you are right. Thermometer is a device that is used to measure temperature. If a temperature is very high, then we say that yes, you got fever. This is a thermometer. Now next we have fundamental quantity. Unphysical quantity are those quantity. For instance, uh, beautiful is a quantity, but it is not. It cannot be measured. Yeah, it cannot be measured. Okay, here We don't need to understand, but yeah, we know that yes, this is a unphysical quantity. We will not see discussion of a beautiful quantity in our physics chapter. No, only we will be exploring physical quantity. That's it. So okay, in the physical quantity we have fundamental quantity, then we have derived quantity. Derived quantity. Fundamental, it would be fundamental, and yes, this is strong. Derived quantity will be made by taking fundamental. Yeah, here fundamental will not depend on any quantity, but derived will be depend on fundamental quantity. Yeah, fundamental quantity is a quantity that is independent, and derived quantity is a quantity that is depend on fundamental quantity. Let's see. Example: mass, length, time. All these are very fundamental. Too much fundamental. This is basic. They are not able to depend on any quantity. And here we have velocity, force, and work in derived quantity. We know that velocity is what? Unit of velocity is what? Meter per second. But here we are realizing what? Meter, then per, then second. Two things. First meter is coming, then second. So this velocity is depend on fundamental quantity. Without fundamental quantity, velocity will not be able to create itself what? Unit. Force, Newton. Force is a Newton. Newton is a fundamental quantity. Okay, so derived quantity, these are derived quantity, and fundamental quantities are this. Fundamental quantity will be fixed. So here v is equal to distance upon time. Yeah, we know. But hold on. Distance of a displacement. Distance of a displacement. Introduction to measurements. Measuring a physical quantity. Here you can see what is happening over here. We can measure something like that just by using this hand like that. And we can also measure anything, something just by using this foot span. We are using over here hand span, and in this we are using foot span. But it was seen that the uses of these parts of a human body is not standard. It will not be sufficient for future, because size of a hand of somebody will be different from the other human. That's why size of all size of a people, size of a hand of a people will not be same. That's why it was said that this is not a standard. We need to bring something else that can measure exact value for everyone. Length of the maths textbook is a two-hand span. Here this textbook, two hand from here, two hand. Comparison. Here we are measuring this just by taking this. Yeah, anything you can take and measure. So here number of these are how much? 8 doubles. So 8 doubles is equal to this. That is what we can say. But it is not sufficient. Anytime you will not be able to use these doubles. Okay. This is a temporary. You can use it as a temporary, but not for permanent. Comparison, then unit. Unit tells you that yes, you are measuring this. If you are measuring liquid, then unit would be what? Liter. So from liter unit, you understand that yes, you are measuring a liquid. From meter, from kilometer, you understand, yeah, you are measuring it. You will be measuring it. Road, or solid material or flexible material. Here comparison with the reference standard. This is what? This is a perfect standard. This, rather than using hand span, foot span, you can use this materials, and it will give you exact value. People who are in other state, people who are in this state, both state will be, people of both state will be using this same. That's why it was this was considered as a standard tools, and these tools can be used anywhere, every time. Representing a physical quantity. Physical quantity 28 meter, 28 millimeter, 28 kilometer, 28 foot or 28 steps. Here 28, it is a number, and mm, km, foot, all these are units. All these are units. Units are telling you that yes, you are measuring something. Only you, if you write only number, then it will be not clear for other people. People will be thinking it is just a number. But for clarity, you can, it will be important to apply these units so that anybody can understand, can interact with this number. They can understand, yeah, this is a measure of this, and measure of this is something. That's why we use this unit. Only number can be anything, can be emitting any meaning. Okay. When we use a unit, then it makes a clarity. Length is 28, but for length we use meter. For length we use meter. Here physical quantity is what? Physical quantity is what? Magnitude multiple unit. Magnitude multiple unit. This 28 is just a number, and this number is what? Is magnitude. But unit, this m is unit. Magnitude is just number. It is just a number in figure, and this m will be considered as a unit. And here you know that length is a scalar. Yeah, 28 is a magnitude. Yeah, we know. Yeah, m is a unit. Now next we have magnitude of a physical quantity. Magnitude of a physical quantity. Hold on. Physical quantity is in INU unit, and NU N2 in U2 unit. Even I didn't understand this, but let's see here. Physical quantity is this equal to this. Okay, no problem. With example, try to clear us. Find the magnitude of a physical quantity length in foot given. Length is equal to 28 meter, and in 1 foot would be how much? 1 foot is equal to this much meter. If 1 foot is equal to this much meter, we are going to convert this 28 meter into this much foot. Here you can see length is how much? This much. This is given already. Just here you will multiply, then by multiplying you will get this much number. So it is telling you that this much meter is equal to this much foot. So both will be equal. Both are equal. Yeah, we know units are different, but we can say that 1 kilometer is equal to 1000 meter, because here in one side we are taking 1 kilometer, and in one side we are taking 1000. kilometer. 1000 meter, not kilometer. Introduction to units. Introduction to units. This is the introduction of units. What is unit? We have seen just after magnitude, we use a unit to express a measurement of something. Fundamental base unit, meter, kilogram. These are fundamental units. Then derived units. First we saw what derived quantity, fundamental quantity. Now we are observing what uh, units, meter, kilogram. Here, meter. As you know that if you write a derived word, then here you are saying that derived units is a depend on fundamental units. Next we have system of units. Complete set of units, okay. Then MK is meter, kilogram, second. MK is which means meter, kilogram, second. Then this is what centi. C would be something else, and yes, C is a centi, and here J is a gram, and here S is a second. This M is a meter, kilo, and this is a second. It is a big, this is less, and this is a more less. I don't know about this. Here MKS, which means meter, kilogram, and second respectively. Here you will realize first M as a length, second K as a mass, and third as a time. These are fundamental quantity, and these are fundamental units of this fundamental quantity, meter, kilogram, second. And here this would be what? Centimeter, gram, second. Centimeter, gram, second respectively. Then next we have foot, pound, and second respectively. This is too much, and this is more than this. This is more than this. And next we have SI system. SI system. SI, which means system, international system of units. When it comes to international, then units will be considered as international. If you are in a country in India and you are using units, for example kilometer, meter, centimeter, liter, all this, then value of all these units will be equally in other country. That's why this was considered as a international system of units. Now by this understanding this international system of units, anybody will be able to interact with this will be telling, yeah, this are units, these are your units. If you use these units, then value of these units will be same in other country. Just have a look over here. seven fundamental. There are seven fundamental units and two supplementary units. Supplementary, which means half half. Seven fundamental units are fixed. Here we can see quantity, name of units. There are seven fundamental quantities. Quantities: length, mass, time. Then electric current. For electric current, unit would be ampere. Temperature, Kelvin. This is something else. And then luminous intensity, candela. Amount of a substance, mole. All these are symbols of these units, and these are units of this quantity. These are fundamental quantities, not a derived quantity, and these are fundamental units. All these are fixed fundamental quantities. You are familiar with this unit for this. This meter is for length. This kilogram is for mass. This second is for time. Ampere is considered for electric current. This Kelvin for temperature. This candela for luminous intensity. AM symbol is for meter. K is a symbol for kilogram. S is for second. A is for ampere. K is for Kelvin. M mole for mole. CD for candela. Yes, this you will have to keep remember if you are able to remember this thing. Supplementary quantity: plane angle, then solid angle. For plane angle, radian, and for solid angle, steradian. I am familiar with radian. I hope you most of you would be familiar with radian. If you are not familiar with this radian, then you will have to take a lecture which is a trigonometric chapter in class 11. Then you will be able to understand this. You will have more basics after taking that lecture. For solid angle, we have this steradian unit, and symbol for this SR, and symbol for this RAD, radian. By practice, we will be able to remember this into. Don't worry. Here this is a radian, and this angle is making on a plane. This length arc, this is known as radian. This arc is known as radian, and we get this arc just by this. Theta is equal to this L upon R. For L, L would be equal to theta multiple R. L is equal to theta multiple R. For L, you will have to multiply this theta by R, and this S is what? It is a radian, and we get radian from this circle. Now, what is a solid angle? Yeah, this is new for me. I hope most of you would be thinking, yeah, this is new for you. Solid angle, wow. Here it is making a cone, isn't it? Yes, R. A upon R square. This R is coming two times, this one and this one. And A is what? This A. We will see it later. Right now I am ignoring it. Here, light travels a distance of 1 meter. Yeah, what is the direction of light? Direction of light is straight. It always goes in a straight direction. Yeah, it can turn into another direction if object is above and that light is falling on that object, then it will turn into one direction. This turning of a light is known as a reflection of light. And here you can see a light is going into straight direction. This is nothing but It is a traveling instant. Here, this measurement of this ray light is how much? 100, 1 meter. 100 centimeter is equal to 1 meter. 1 meter is equal to 100 centimeter. So measure of this light is how much? 100 centimeter or 1 meter. Now next we have measurement. Measurements of length. Let's see. Direct method. We can measure any length of anything through direct method. And then we have another indirect method. Let's see first of all direct method by meter scale. Yeah, just by meter scale that we saw right now. Then accuracy of this much by when you calculate. This is for you. And the measurement of very large distance of a planet from Earth. Then indirect method we will use. For a small things we can use this direct method, but for large material things which is impossible to use this meter scale, then indirect method will be used. Measurement of a very small distance, diameter of a molecule. Yeah, for very small we use a extension device. Measurements of a large distance such as the distance of a planet or a star from the Earth. In that case, we use a parallax method. This is method which name is a parallax method. This method will be used. It is used to measure a distance between Earth and Moon. We know that this is a very impossible with the help of possible to measure that this distance between them with the help of a physical measurement. That's why there is introduced a method which is a parallax method. It will give you a measurement of between them. Here we have a tree and this is a tower. AB is just a height from here to till here. Now tell me, what is the distance from here to till here, and what is the measurement from here to till here? We know that this is making an angle, and both will be making different angle. This right here, just opposite of this would be same, angle would be making same, because of this from here to till here is equal to this from here to till here. This is left, this is known as right side, and this is the left base. Okay, parallax method. In the parallax method we generally see a trigonometry. Okay, here we can see there is a sun, and this will be considered as a perpendicular or height. With the help of a trigonometric function, we can find the height of anything which is impossible to measure them with the help of a physical measurement. Parallax angle. Okay, this is making angle, yes, we know, and this is B is a basis. Then we will draw a imaginary line which should be horizontally. We will explore it in details later, but right now I am ignoring for you. Here, estimation of a diameter of a star by parallax method. That is how we can predict measurement of this star. We are over here. You can take yourself as a observation. Measurements of a very small distances. Till now we saw measurement of a very large distances. Now for very small distances, size of oleic acid is how much? One centimeter raised to power 3. Solution with the alcohol this much. Measurements of mass and time. We saw measurement of length. Now let's see measurement of mass. Here mass of commonly available objects can be determined by a common balance. Here if in this side weight of the material is 600 gram and in this side 400 gram, then both are unbalanced still. But here it is telling you that this side should be more 200 gram, then both will be balanced. That is how we do balance. Okay, here we use a weight machine so that we can balance the things. There is a machine called weighing machine. That machine is used to measure weight weight of the material. Large masses in the universe like planets, stars, etc. can be measured by using gravitational method. Yeah, gravitational method. Okay. Large masses in the universe, right? So all this can be measured just by using gravitational method. For this planets we will use gravitational method. It will be very sufficient and very easy to bring masses of these planets, which are very large objects. Measurement of small masses of atomic, subatomic particles, etc. We make use of mass aspect. This is for you. You read this. Next we have range of masses. For electron we have this much masses. Mass of this electron is this much, very less, because here we have exponent in negative. It is telling that this is very less. Proton, it is also very less, too much less. Rhenium atom, here you can see all this total here, total grape, these are how much? Very less, but this is very less, and then it is increasing gradually. Now mass of the human is considered as a what? 10 raised to power 2, which is 100. It is a normal. Automobile 10 10 raised to power 3. Boeing aircraft, for Boeing aircraft, wow. For moon this much, for earth this much, 10 raised to power 25. For sun it is a 5x time more than earth. Then Milky Way galaxy 10 raised to power 41. Then observable universe 10 raised to power 55. You can see masses of these objects. Here electron mass of electron is very less. Proton, yeah, dust particles, very less mass. You can imagine dust. This is talking about dust, very less mass. And we know that mass of the human can be measured easily, but when it will come to dust, proton, electron, then it will be very difficult to measure them. Then in that situation we use devices which are made for measuring this type of objects. which are impossible. Atomic standard of a time. Cesium clock. 1 second is equal to time needed for this vibration of the radiation. This is for you. Ready for challenge? This is question. I will see it later. Right now, my focus is on understanding the concept. Errors, accuracy and precision. Error, other word, other meaning of this would be wrong. Every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Every measurement by any measurement. Let's expand this. Accuracy, precision. It is a measure of how close is measured value to the true value. And precision is it tells us to what resolution or limit is the quantity measured. Even I didn't understand this AB. Okay, that is giving us a line. True length, we know that this would be fixed. There would not be any kind of error. Yeah, we know that there would not be any kind of error for measure this line. Then okay, here it is giving you this much, which is exact. Resolution instrument 3.5, but it is how much? 4.7. Here it is a device that is used to do something. We can also use this for a small material, to measure a small material, just by using this. Here we have this scale. Here we have this scale, and this is used for a small thing, and it can be also used for normal size of the object. Less precise but more accurate. Less accurate but more precise. Accurate, which means at the center, but inaccurate, which means not at the center. Imprecise, which means at the center, but inaccurate, not at the center. Here you can see what is happening. Precise, in the case of accurate, both are at center, but in the case of inaccurate, both are not at center. These are questions for you. Errors in measurement. Let's see. First is the systematic errors. The next is the random errors. Systematic errors. Source, personal errors. Random errors. Then list count. Calculation of errors. Absolute errors, values obtained in several measurements, or there are calculation, relative error, then percentage error. Yeah, this is how percentage error is found out. This is question, then okay, again question. Then we have errors in measurement, propagation of errors. Density, errors in measurement of mass. Okay, it is a continue. This error is a continue. Then we have significant figures. Oh, whatever will left, we will discuss later in separate lecture. Till now, that's all for this lecture.